Hi, welcome back for another day of online chemistry. Today's learning target is to recognize and name molecular, also known as covalent compounds. Now, we've been working with ionic compounds, starting with the evidence that there are things made of ions. Remember that evidence was that when we dissolve them in water, they conduct electricity. They don't conduct electricity in the solid state, but when we dissolve them in water, they conduct electricity, and you need something with a charge that can move in order to conduct electricity. So scientists figured that the water solutions must contain ions, something with a charge, and since the compounds were neutral to begin with, there must be both positive and negative ions. And then they figured that the solids themselves were made up of ions, alternating positive and negative ions in an endless array, positive, negative, positive, negative, positive, negative, forming a great big crystal. And you named those. And of course, one really important aspect of their naming is there's only one way for any two ions to combine. And so the name just has to tell you the two ions, and from the names of the ions, you can figure out what the formula is. Okay, covalent compounds are totally different. All right, first of all, recognizing them is one of the important things you have to do. You can recognize them based on their formula by the fact that they only contain nonmetals. Maybe metalloids. Most of the ones you're going to look at are going to be nonmetals, but it's true that they can contain metalloids as well. All right, they are totally different from ionic compounds. They have different properties. This is like the sugar that dissolved in water does not conduct electricity. These things are neutral. They do not separate in water. They are held together not by oppositely charged ions sticking together. They're held together by something called covalent bonds, and that's why covalent is another name for this kind of compound. Got an extra line there. They form molecules. Molecules are small groups of atoms tightly bonded together. I have pictures of some molecules over here. Small groups of atoms. They're using different colors to represent different elements in this representation. And in a minute, I'll show you some more pictures of different ways that chemists represent molecules. Now, recall that in ionic compounds, there are two ions, always two ions, one positive, one negative, and there's only one way that you can combine those two ions to make a neutral compound. Molecules are different. First of all, they don't have any ions. Second of all, two elements can combine more than one way. They can combine a whole bunch of different ways. For example, you've heard of CO and CO2, carbon monoxide and carbon dioxide. Okay, that's two different compounds with carbon and oxygen combined in more than one way. And this goes back to some of the stuff associated with Dalton and the first explanations of chemistry that, elements combine in fixed ratios, but certain the law of multiple proportions, they can combine in more than one fixed ratio. And then when you take the ratio of the ratios, you get a simple number. What does that mean? That means one oxygen to one carbon, two oxygens to one carbon. That ratio is 2 to 1, simple whole number ratio. Look at nitrogen and oxygen. Okay, there's a whole bunch of compounds of nitrogen and oxygen. So the names have got to tell us how many of each are in there. We no longer have the luxury of, like with the ionic, just naming two ions and saying, hey, there's only one way these guys can combine, so all we have to do is tell you what's in it. We have to tell you how many of each are in the molecule. And so we're going to use fake Greek prefixes, Greek-sounding number prefixes, to tell you how many of each. Let me just tell you the names of all these nitrogen and oxygen compounds. First one is nitrogen monoxide. Second one is dinitrogen monoxide. The third one is nitrogen dioxide. Then we have dinitrogen trioxide. Then we have dinitrogen monoxide. Then we have dinitrogen tetroxide and dinitrogen pentoxide. So you're probably getting an idea of what the pattern is. So the names have got to tell us how many of each element are in the molecule. These are some representations of molecules commonly used in chemistry. So on the lower left, we have something called a ball and stick representation. You can probably figure out why it's called that. The balls represent atoms. The sticks represent these covalent bonds holding them together. And we will learn more about covalent bonds down the road a little way. A lot of the time it's thought that representing the atoms by much bigger balls and not showing the stick between them gives you a better idea of what the shape of the molecule actually is. And with the help of computer modeling, we've come up with what are called space filling models. Okay, so both of these two in the middle represent water. Red is commonly used for oxygen in models. White is commonly used for hydrogen. The oxygen atom is considered to be significantly bigger than the hydrogen atom. So here is a ball and stick representation of water. Here is a space filling representation of water. Here are some more small molecules. Here's two different representations of NH3, ammonia. Sorry that my picture is covering that up. I forgot about that when I put this slide together. But anyway, you can see these are small groups of atoms. They are held together. The ball and stick models represent the bonds as sticks. And you can see that the bonds connect. In all the molecules we're going to study, bonds connect two atoms together. And all together, the atoms form a cluster. So we're going to work with this some more down the road. I wanted to show you what some molecules look like. So today we're going to work on naming these things. The system of naming has got to tell us not only what elements, okay, we're not talking about ions now, we're talking about elements, what elements are in the molecule and how many of each. All right, let's get started. I'm going to let Tyler DeWitt explain this one today. Take care. Have a good day.